Hello, welcome to Z Talk. Starting this video, I'd like to kick off a new series of sessions about Kubernetes. I know I have involved Kubernetes a couple of times in my previous sessions, like setting up Prometheus and Thanos, right? With the technology trend moving to, everything containerized, microservices architecture, I believe Kubernetes has already become one of must-have skills for all DevOps engineers. So I think it will be beneficial to learn Kubernetes more systematically from the beginning. Basically, that's the goal for this series. All right. So today's session, I'd like to start with talking about Kubernetes administration. All right. A quick introduction of what is Kubernetes. Kubernetes is an open source orchestration system for containers. It was designed by Google and is now maintained by CNCF. Some key takeaway of Kubernetes capabilities. It lets you schedule containers on a cluster of machines. So you can run multiple containers on one machine or across the board. It's also able to host your long-running services like your web applications. Kubernetes manages the state of these containers. Like it can start a container on specific node or nodes. It can start a container when it gets killed automatically, or it can move containers from one node to another. Also, Kubernetes clusters can be flexible. Like it can start with like something small, like for example, only one single node, and then roll up to thousands of nodes based on the load or requirements. Right? That's a power of these orchestration system. Some key advantages. Technically, you can run Kubernetes from anywhere. If you own your like on-prem, if you own your own data center, or public. All those public cloud providers, they provide their own CaaS solution, which is container as a service, right? Or hybrid. It can be hosted either public or private or both, right? Another advantage, of course, as a open source solution, is highly configurable, and what's more, it has great active community to support this product. So every time when you run into issue, just throw questions over there, you will get answers or help real quick. That's good things about these Kubernetes system. Right? All right. Setup. There are multiple ways to run a Kubernetes cluster, like Minikube or Docker client, which we have gone through in the previous session when we set up Prometheus and Thanos, right? So the installation is pretty straightforward. Just Google Minikube and follow the instruction right here, and you can spin up a testing Kubernetes environment real quick in minutes, right? And again, Minikube or Docker client, they are great tools for local setups. So it's really just for if you want to play with Kubernetes and testing on your laptop, they are great. But they are not designed for managing real production grade Kubernetes clusters. You need for that, for running production grade Kubernetes clusters, you need some more powerful tools, or like Kops or kubeadmin. Kops, stands for Kubernetes operations, right? So basically, it allows you to do production grade Kubernetes cluster installation, upgrades, and management. Or the third way to run the Kubernetes clusters, which is like I just mentioned, CaaS solutions. container as a service. All those major public cloud provider, they provide their own CaaS solution like AWS EKS, Elastic Kubernetes Service, Azure's AKS, Azure Kubernetes Service, and GCP's GKE, Google Cloud Kubernetes Engine. All right, so let me pause here a little bit. Because I guess there might be some confusion right here. If you watch my previous videos about Terraform, we had a session talk about EKS on deployment via Terraform on AWS, right? And here I just brought up a new tool called Kops, and I mentioned you can run Kubernetes on AWS by Kops or EKS. So I guess there might be a confusion right here. So what's the difference? Well, there are two popular methods for running Kubernetes on AWS or any public cloud provider. Firstly, you can do like everything manual. You can manually set up everything on EC2 instances and use Kops to manage your cluster. Or you can use, like I mentioned, their CaaS solution, like EKS, to manage your cluster for you. So the number one difference is EKS is a managed service by Amazon that you can use to run Kubernetes on AWS without needing to install, operate, and maintain your own Kubernetes control planes or nodes. However, the trade-off is that you do not have access to the master nodes and you are not able to make any modifications to your control plane, right? By the way, we call master nodes etcd and API server combined as control plane, if you're not familiar with those terminologies. On the other hand, you're going to own the Kubernetes infrastructure. Kops is the Kubernetes community's official supported method for setting up and maintaining Kubernetes clusters in the cloud. Technically, Kops is a CLI tool for prog-grade Kubernetes cluster installation, upgrade, and management. All right. Okay, demo time, I guess. Let's build up a Kubernetes cluster on AWS via Kops. So also you can play with EKS. Maybe go back to my previous session about Terraform. You can see how do you set up a Kubernetes cluster on EKS. So either way, so for this demo, I will show you real quick how do we build up a Kubernetes cluster on AWS via Kops, which is Kubernetes operations. That's the CLI tool. All right, cool. One more thing, again, thumb up if you like this video, and subscribe my channel if you haven't done so, and leave comments if you have any questions. All right, cool. Okay, switching to my terminal. There are some prerequisites that you have to take care of before you're able to deploy your Kubernetes cluster via Kops, right? You need to make sure that AWS CLI, Kops CLI, and Kubernetes CLI are all installed on your machine. Just follow the official instruction of each. It's pretty straightforward. If you also use Mac, like I do, all those CLIs can be installed via Homebrew, which is always the easiest way for macOS, right? Okay, once all CLIs are installed, just test it out by issue like AWS, Kops, and kubectl. If you got something returned like this, you should be good to go. All right. For deploying Kubernetes cluster on AWS, Firstly, you're gonna need to set up an IAM user. You can create a dedicated a user for Kops, or you can use any of your existing user as long as the user has necessary permissions for Kops to function properly. As per the documentation right here, for Kops, you're gonna need these 5 permissions to function properly, which are EC2 full access, Route 53 full access, S3 full access, IAM full access, and VPC full access. All right. So now go ahead, create your IAM user. You can do it on AWS console manually, or you can issue these AWS CLI commands one by one to do the same thing. Basically, what this section does is to firstly create a user group, and then attach those required policies or permissions to that group, and create a user and add the user to the group you just created right here. And last but not least, create the access, the private information for that ID that you just created to be able to get access to your AWS account. That's pretty much what this section does. All right. So back to my demo, log on to IAM. So here I already created the user ahead of time. If you can see, I got 2 user groups. One is Kops, and go inside of it, and there was a user called Kops as well, added to this group. This is the user ID I'm going to use for Kops CLI to create the cluster. All right. So one more thing. Once the user is created, you're going to need to set up some environmental variables. A good example is those private key access secrets. You're gonna export them out, because AWS configure or AWS CLI does not export those variables for Kops to use out of box. All right, so just switch back to my terminal, and what you need to do here, you just need to create a variable and export it out like this. Copy these and to export the access key, and then another variables to export the secret key. All right, that's it. Now we can go ahead, move to the next step, configuring DNS. All right. So in order to build a Kubernetes cluster with Kops on AWS, you're going to need a Route 53 service to build the required DNS records so that Kops CLI is able to communicate with the Kubernetes cluster that you are going to build via that DNS. That's another important requirement. So if you follow my channel, I talk about Route 53 a little bit in my previous session about Terraform for installing Elk Stack, right? Here I attached that video, so feel free to jump over there and take a look at the section where I talk about Route 53. Because for this demo, basically, I'm going to do the exactly same thing. I'm still going to use that domain that purchased here on GoDaddy. And here, this guy, zztalks.xyz. And, once the Route 53 is configured, once that hosted zone is created, I'm still going to grab those name servers and update on GoDaddy here. Right, so let's do that real quick. Switch back to the AWS console. Again, here you're free to use AWS CLI or from console. Either way works, whichever you are comfortable with. right? So let me jump to route 53. Okay, I already create the hosted zone here, and I give the name, the node domain name as kubernetes.zztalk.xyz, right? That's the domain I purchased right here. Okay, so if you click, go inside of it, the domain, and so you can see there were already 2 records being created, automatically once you created the hosted zone, right? And these list of name servers is the ones that you're gonna update on GoDaddy, right? So back to GoDaddy, I already update the name servers here. Cool. So once the name servers are updated, you can do a little verification. Like go to your terminal. Just use the host utility. Host and put in the name server, the domain name that you created. Like for me, is kubernetes.zztalk.xyz. So it's supposed to return all the list of name servers, right? So you see here, those exactly the name servers right here. So good here. So this is pretty much the configuration of DNS. Moving to the next step, once we had IAM user, we had DNS configured, we still gonna need a dedicated S3 bucket for Kops to store the state of your cluster and the representation of your cluster, because these buckets will become the single source of truth for your cluster configuration, right? So let's do that. So switch back to my AWS console and let's see if I got that bucket created yet. Check S3, click that. All right, I haven't created the S3 bucket yet. So, okay, let's do it together. I'm gonna use the AWS CLI to create the bucket, and let me jump to my terminal. All right, so I'm gonna create a bucket in US East 1 region. So I will issue AWS S3 API and create bucket, and I'm gonna call this bucket Kops hyphen state hyphen store hyphen ZZ talk. All right, and the region will be US East 1. Hit enter. Here we go. This is the JSON returned. As you can see, we got a bucket created. So let's exit out and switch to the AWS console, refresh. We should be able to see a bucket right here being created, right? Once you got the bucket created, it's strongly recommended versioning your S3 buckets just in case you need to revert or recover a previous state store, all right? So for doing that, you can issue AWS S3 API and put bucket versioning. The bucket name is Kops state store ZZ talk, and versioning configuration and state equal enabled. Let me copy the command right here. All right, so that's it. So the versioning has been enabled. Let me create another environment variables. Basically, I'm gonna create a variable called name, and I'm gonna assign the name of the Kubernetes cluster that I'm gonna build here to these variable environment variable. I'll call it kubernetes.zztalks.xyz, right? And another environment variable I'm gonna store the S3 bucket like this. I'm gonna create a environment variable called Kops _state _ store, and this is the S3 buckets that we just created, right? So hit enter. All right, that's pretty much it. We're good to create our first Kubernetes cluster via Kops. So let's do that by Kops create cluster zones equal US East 2A, right? So I'm gonna give the name of this Kubernetes cluster as the one I define in this environment variable. So I'm gonna call this environment variable name, right? Hit it. Yeah. As you can see here, the cluster configuration has been created, right? So, and here it also list out the suggestions how do we check the cluster, right? Using Kops CLI, this command, and also how do you gonna review the configuration or modify the configuration if needed for the cluster and for different groups. As you remember, so like what I mentioned, the comparison between deploying Kubernetes cluster via Kops and EKS. So the number one difference, or the key difference, is for EKS. So basically, Amazon manages the control plane, the master node, for us. We don't have to do anything about it. But on the other hand, for Kops, basically we own everything. We own the infrastructure. We have to maintain the control plane along with the nodes ourselves. That's the benefit is we got more control over our Kubernetes cluster, right? So that's the biggest difference. And here let's check the Kops. Run this command to check the cluster status. And here we go. As you can see, there was this cluster Kubernetes.zztalks.xyz was created, and it was hosted on US East 2A availability zone, right? And next, let's check the configuration of these cluster by issuing these commands: Kops added cluster and the name of the cluster. Here we go. Here you can see a YAML configuration. Basically, here it lists out all the system configuration for our cluster. And as you can see here, those were the detail of etcd and CPU memory allocation and kubelet, all those the key components of Kubernetes cluster, right? And what I want to modify a little right here is I want to change the Kubernetes version. You see here, the version is gonna deploy is 1.21.5. I want to change it to 0 because after these deployments, I want to show you how easy it is to upgrade or Kubernetes to a newer version via Kops. That's why I put the version as 0 right here as the initial deployment, so that I can upgrade to a high version. So you may know, so maybe right now the latest version of Kubernetes is not the 21. There's the 1.22 already released, but for Kops, you have to check the check Kops which version, what's the latest version is supported. So it's not the latest version, but I think the latest version is supported right now is 1.21.5. All right, so that's why I just change it to 0, so that I can show you real quick how do we upgrade our Kubernetes cluster after the deployment. Right, that's the only thing I want to change right here. So let's save it and exit out. Right. Next step, let's also check out the configuration of the node instance. So here node instance is basically where the pods, or application pods will be hosted is inside this group. And master group, as I mentioned, that's basically the control plane is hosted, right? So let's go to Kops edit node instance group. Here we go. So here, as you can see, the max size is set as 1 and minimum size set as 1 as well. Like I mentioned, it's pretty flexible. It can start with something really small with 1, and we can scale it out based on our requirements, right? So I'm gonna change it the max size from 1 to 2 here because again I'm gonna show you how do we upgrade. For upgrading our Kubernetes cluster, it's gonna require at least 2 nodes for a rolling upgrade, right? Because normally the procedure is, so when we need to upgrade the cluster, it's gonna automatically spin up another new node. Let's say node 2, right? Or existing node, let's say it's node 1. So once the node 2 is up and running, so it's gonna train node 1. Basically, it's gonna move all the pods that are hosted on node 1 and move them all to node 2 temporarily. And then once the node 1 is trained up, it's gonna perform upgrading. So once the upgrading is done, it's gonna move all those pods back from node 2 to node 1, and then kill node 2. That's basically what's gonna happen for a rolling upgrade, right? So that's why I'm gonna change the max size to 2 so that it's able to scale out when we issue the command to upgrade our cluster. All right, so that's the reason I changed the configuration right here. So let's save it and exit out. All right, so that's pretty much all need to be done right here. So now we're good to go to firstly create our cluster. Okay, jump to my terminal. So let's issue the Kops command to create our cluster. Note here, so this is the command. Kops update cluster and name of the cluster, and remember when you need to do that to use this yes argument, you need to include that. So hit enter. So it's gonna take a little bit of time to create the cluster. Let's be patient. Also, let me switch to the EC2 instance so to verify. Basically, what we're expecting, there should be 2 EC2 instance spin up in US East 2 region. All right. Oh, it's faster than I thought. So cluster is starting and it should be ready in a few minutes. So let's give it a little bit of time. So here again, it's list out some suggestion commands so you can check the status of your cluster. So here, let's run these validate cluster commands to make sure our cluster is good to go. As you can see, there are 2 instance groups, one for master and one for nodes, right? And this was the configuration. You see, we just modified the max node number of nodes for node group from 1 to 2, and here we go. But by default, when it's spin up, it's still gonna spin up one node right here. So the cluster is still not healthy yet. So let's give it a little time, and it's gonna keep checking the status or the health of our cluster. So it's gonna take some time to to make sure all those connection is good. All the connections are good. And here, jump to the terminal. So let's refresh. There should be 2 EC2 instance created already. As you can see here, the status check still initializing. So once it's stabilized, we can the or cluster should be ready. Refresh. All right, now the status of both nodes turn to ready. You see here, ready shows true, and switch back to the console, and you can see the status of both EC2 instances turn to green right here. Right. You can also issue kubectl get nodes to get the information about your cluster, like version, right? Like right now it's 1.21.0, right? So like I mentioned, I'm gonna show you how do we upgrade our Kubernetes cluster to a higher version, right? It's pretty simple. So all we need to do, we need to run that edit one more time by kops edit cluster and the name of the cluster. I'll give the name cluster, hit enter. All right, all we need to do, we just need to change the version back to 1.21.5, right? So basically that's the ideal state. So once we run that Kops update, it's gonna check the configuration and to see if the current version matches the one we desire, the version we required in the configuration. If it doesn't match, it's gonna upgrade the cluster to the version that we configured in the configuration file, right? So here, once we added the back to the edit, once we added the version right here, just save it and exit out, and then you need to issue the same command, kops update. Here, note this is the command is update, not upgrade, right? So update the cluster and name. Remember, use that argument yes. Hit enter. Yeah, as you can see, it says cluster changes have been applied to the cloud. Changes may require instance to restart by issuing kops rolling update cluster. So let's follow the instruction and issue this command. Remember, we're gonna do a rolling update, and you will see when it's perform rolling update, it's gonna spin up a additional or an extra node and string the existing node to perform upgrade, like I explained earlier, right? Let's run this command again, remember, add that yes argument. Hit enter. So it's basically the order is it's gonna upgrade the master node first, and then it moves to the workers, right? For workers, it's gonna spin up an extra node and drain the existing and then upgrade, and then move everything back to the existing node and kill the extra or temporary one. That's basically what's going to happen. It's going to take a little bit while. Let's watch the just keep an eye on the terminal to make sure we don't run into any errors. Yeah, you see here is stopping the node instance. So let's check over here, refresh. See, the master node, like I mentioned, is gonna perform upgrading on master node first. So that's why it's gone. And yeah, so because for our demo cluster, there's nothing running on the cluster, so the upgrades should pretty quick. Maybe a couple of minutes, it should be done. So let's wait for it. So here you can see right now it's showing cluster did not validate because still the upgrade is going on. The master node is down. That's why you don't you got these timeouts. That's okay. Here we go. The master node is up and running, right? So it's still initializing. Once it's stabilized, the upgrade will move to the node group. All right. All right. Looks like the upgrade has been completed successfully. As you can see here, rolling update completed for cluster kubernetes.zztalk.xyz, right? And back to the console, and you can see the status check show green for both nodes right here. And if you issue a kubectl get nodes, you can verify the version, right? So you can see the version has been upgraded to v1.21.5 for both nodes, right? All right, that's pretty much what I want to share for this session. Oh, by the way, if you're interested in integrating Kops with Terraform, that can be done. Actually, there's already modules available on Terraform registry here, like this one. This module is for creating Kubernetes clusters using Kops. So feel free to play with it if you want to integrate with your Terraform infrastructure. Right? Cool. Another thing, back to the official documentation, and you can see there are multiple projects going on. Basically, Kops, they're working on cross-platform projects. Like, it's not only just for AWS. You're good to deploy Kubernetes cluster via Kops on other public cloud provider like GCE and Azure and OpenStack, DigitalOcean. So those are on some of them in beta or some on the alpha stage. So keep an eye on it if you're using other cloud provider. So give it a try. So it's already available following the instruction. So maybe because it's still not finalized or it's not in GA, so maybe you will run into bugs somewhere, but it's worth a try. All right. So that's pretty much for this demo. Okay, so we got some takeaway. So we got our first Kubernetes cluster up and running, and we also tested the cluster, upgrade via Kops, and the upgrade was successful, right? In next video, we're gonna dig into the key components to learn more about cluster administration. So if you are not familiar with key components or processes of the control plane, here I attached. I like to share a really good introduction that I found on YouTube. It uses a good analogy to help you understand the infrastructure of Kubernetes easily. So, like, what's the responsibility of each component? So check it out. All right. And also, I will in the next video I will explain more in detail the responsibility, what each component does. All right. So thanks for watching, and I will see you next week.
Alright, thank you for watching my video. If you think this video is helpful, you're more than welcome to leave any comments. Remember, thumb up, subscribe my video, and also hit the notification bell. See you next time.